GCC Chem 130 students, we're going to continue on with our Chapter 15 discussion. This is the third video. So we're going to now use the words miscible, immiscible, soluble, or insoluble correctly. So if we have a polar liquid solute and we put it in a polar liquid solvent, what word would we use? They're both polar, they're both liquids. So are they going to mix, both being polar? Yes, they'll mix. And what's the word we use with two liquids? Miscible. Yes, it's miscible. Good job. Okay, now what if we have a polar liquid solute and we put it in a non-polar liquid solvent? So they're both liquids, but one's polar and one is non-polar. Yeah, that won't mix. That's called immiscible. Very good. Okay, now we have a non-polar liquid with a polar liquid solvent. So will those mix? They're both liquids. So immiscible is correct. I hope you said that. All right, finally we have a non-polar liquid solute in a non-polar liquid solvent. So two liquids, they're both non-polar. Miscible. They will mix because they're both non-polar and they're both liquids. All right, now we're going to put a non-polar solid in the polar liquid solvent. Polar solid, polar solvent. Okay, so that would be soluble. Good job. Okay, what about if we have a polar solid and we're going to sprinkle it into a non-polar solvent? Okay, yeah, that's not going to mix. So what's the correct word for a solid in a liquid? If it won't mix, insoluble. Very good. Finally, we have a non-polar solid in a polar liquid solvent. So non-polar and polar won't mix. Yeah, insoluble. And then a non-polar solid in a non-polar solvent. They're both non-polar, so that will mix. Soluble. Very good. Now here's a tricky one. What if we have an ionic solid in a polar liquid solvent? An ionic solid is something that has a plus and a minus, like calcium bromide, potassium chloride, metal and a non-metal. So what's that going to do in a polar solvent? Well, if it's water, you have to look at your solubility rules. So yeah, check your solubility rules for that solvent. If it's water, we have the solubility rules on our periodic table right here. All right, what about an ionic solid, which is plus or minuses, in a non-polar solvent? Would those even want to mix? We have charges, and non-polar is no poles, no charges. Yeah, so that won't mix. So that's going to be insoluble. Very good. All right, moving on. The dissolving process. We have a couple of movies that I want you to watch, also up on our website about dissolving. So I want you to take a look at those. And notice in the corner here, see how the sodium ion is surrounded by water molecules? But sodium is a metal, so it's positively charged. It's cation, so sodium is +1. And then the waters have a little bit minus oxygen end and a little bit positive hydrogens. Okay, so water is very polar. So we have a plus minus ends. We have two poles, polar. So all the oxygens are going to point in towards that sodium ion because opposites attract. So the little bit minus oxygens are pointing in towards the positive sodium since opposites attract. So they orient themselves that way. So if we had Cl minus ion, what would point in towards Cl minus? You're correct if you said the hydrogens. The hydrogens are a little bit plus, so they're going to point in towards the negative chloride ion. Yeah. So concentration. Concentration is the amount of solute in a solvent with a number. So this is going to be quantitative. So we have a couple of units for concentration. We have mass percent, it's a percent, and we have molarity with a capital pointy M. It has to be a pointy M, not a cursive M, a pointy M. And I'm going to talk about those in the next video.